This video is going to review the circulatory routes to the arms and back to the heart, the legs and back to the heart, or in sharks to the pectoral and pelvic fins and back to the heart. So if we were to begin with the shark, deoxygenated blood returns to the sinus venosus, to the single atrium, to the single ventricle, from there into the truncus or the conus arteriosus, and then it gets sent to the gills to get oxygen. And so there is a ventral aorta running on the ventral side of the body from this conus. The ventral aorta here in blue then forms these afferent arteries, which then reach the gills. So here you see that ventral aorta sending off afferent branches to the gills to receive oxygen. Here you see the gill filaments where gas exchange occurs. The oxygenated blood then returns through what are referred to as efferent arteries on the dorsal side of the body. And while these do fuse to form a dorsal aorta, which will then proceed towards the legs and tail, the subclavian arteries come off of these. So here you see the efferent arteries from the dorsal aorta, but the subclavian arteries, which will go to the pectoral fins, then come off of these efferent arteries, reach the fins where gas exchange occurs, and then a subclavian vein will empty into then the common cardinal vein, which goes into the sinus venosus, and the process starts again. Just one quick comment. I'm obviously not referring to lampreys or hagfish here because they do not have pectoral fins. The first fish lacked pectoral fins. There were some fossil jawless fish which possess pectoral fins, which obviously we don't have to dissect. So the shark would be the most primitive animal alive today with pectoral elements. And so this then is how it would send blood to its pectoral fins. If we were to then look at the frog, the arms of amphibians evolved from the pectoral fins of sarcopterygian fish. And so, these same vessels are important. So deoxygenated blood comes from the sinus venosus into the right atrium. Amphibians have separate right and left atria. So into the right atrium to the single ventricle, which then pumps blood into the pulmonocutaneous artery, into the lungs through a pulmonary artery. That's where gas exchange occurs, although in all amphibians, gas exchange can also occur in the skin. So now there is red oxygenated blood, which returns to the left atrium, to the left, I'm sorry, from the left atrium into the one single ventricle, once again, into the aorta. Now, just a note on the aorta is derived from the third aortic arch. And since there are gills on both sides of the body, in fish and invertebrate embryos, they start off as two separate third aortic arches. In this illustration, here you can see one of them, here you can see a second. So while mammals will only retain one, the one on the left, birds retain only one, the one on the right. Some animals can retain both of the third aortic arches, left and right, and we can see that here in the frog. Let's see what that looks like. And so that one. So notice the heart is up here, and then each side of the body produces an aortic arch derived from the third gill arch. So there's one, there's the other, and they then fuse to make a dorsal aorta. So I know that sounds odd to us because we only have one, but notice that, coming from the region of the heart, there are two separate third arches, and they then fuse to make that dorsal aorta. Once again, here you can see that, again, there are two separate systemic arches. From the arch of the aorta, then a subclavian artery goes to the arm to an axillary artery to a brachial artery. This is all just the same artery. We just change its name depending on where it is. The subclavian in the region of the clavicle, axillary in the region of the armpit, brachial in the arm. There are capillaries in the arm, and then there would be a brachial vein, an axillary vein, a subclavian vein emptying into the anterior vena cava and the sinus venosus. And so off the arch, off the dorsal aorta, we would see here the subclavian, then in the armpit forming the axillary, which then forms the brachial in the arm. And so that is how frogs would get blood to their arm and back. Salamanders likewise get blood to their arm and back. And then we see, much the same. Once again, blood can go to be oxygenated in the lungs, which most salamanders have. Salamanders can perform gas exchange with the skin, but the blood vessels which service the skin can vary, going from salamander to salamander. So either way, the blood becomes red and oxygenated, and it then goes into the arch of the aorta. There are two, from there to the subclavian arteries, to the axillary arteries, to the brachial arteries, to the capillaries of the arm, and then we can return brachial vein, axillary vein, subclavian vein, and the common cardinal vein. Now, you may remember the cardinal vein in the shark, and we'll see that again in the circulation to the legs, where these are veins from fish. Humans, we have cardinal veins, but only as embryos. And so we develop multiple blood vessels, but they can be remodeled over a part of our time. So the axillary vein empties into the subclavian, into the cardinal vein, before then returning to that sinus venosus. Okay. If we were to then consider the turtle, there are still separate left and right atria, and only a partial interventricular septum. So once again, there is just one ventricle in reptiles, which is only partially separating the oxygenated and deoxygenated blood. Blood will go from the pulmonary trunk, to the pulmonary artery, to the lungs to become oxygenated, come back, the pulmonary vein to the left atrium to then be sent out. And then this oxygenated blood is sent from the ventricle into the aortic arches. Once again, these are derived from those third gill arches, and turtles retain both of them. All right, so there will be those two. But that will come into play when we talk about blood flow to the leg. Here, before we get into those arches, the brachiocephalic arteries will branch off. Mammals have only one brachiocephalic trunk or artery, but turtles will have two. So from the ascending aorta, as on either side as it's going around, we see these brachiocephalic arteries, which then form subclavian arteries in the region of the clavicle, axillary artery in the armpit region, brachial artery. Gas exchange occurs in the capillaries of the arm, and then blood would return through a brachial vein, an axillary vein in the armpit region, a subclavian vein, which would then empty into a precava or anterior vena cava before coming into the sinus venosus. And so if we were to look at dissections, the subclavian would then go into the axillary, which would then go to the brachial. All right, and I have some video tracing the blood flow through the lungs. Again, so from the ventricle, the red oxygenated blood would go into brachiocephalic arteries on both sides. And then there would be subclavians on both sides, and from there to the axillary region. The carotid arteries would then go to the brain. We would see the same in birds because a wing of a bird is just a modified arm. And so the same, pattern of circulation, we could see uh, uh, sends blood to the wings of birds as well. The big difference is, once again, birds completely separate the oxygenated and deoxygenated blood because they have a complete interventricular septum separating the right and the left ventricles. So there are two anterior vena cava or precava that empty into the sinus venosus. From there, blood goes to the right atrium, right ventricle, pulmonary trunk, to the pulmonary arteries, to the lungs, to the pulmonary veins, to the left atrium, the left ventricle. And from there, oxygenated blood can be sent out to the wings, which obviously need a good oxygen supply. There are brachiocephalic arteries coming off the arch of the aorta. Now remember, there could be two arches of the aorta from both the left and the right third aortic arches. Mammals will keep the one on the left. Birds will only keep the one on the right. So this is only the right systemic arch. Off the right systemic arch come brachiocephalic arteries, right and left. Mammals only have one, birds have two. And then the brachiocephalic arteries will split to the carotid, which goes to the brain, and the subclavian, which will then go to the arm. And so the subclavian artery will then go to the axillary artery, to brachial arteries, and then there are various arteries and capillaries in the arm. Then the deoxygenated blood will return: a brachial vein, an axillary vein, a subclavian vein. The two anterior vena cava, one on either side, empty into the sinus venosus. And then as we look at blood vessels in mammals, I do have videos. I stress in my human anatomy and physiology classes. But in addition to those, I have one on the opossum. Once again, mammals have a complete interventricular septum separating their deoxygenated and oxygenated blood. So here you can see in the opossum, once again, we only have the one aortic arch on the left side. There is a brachiocephalic trunk, and the subclavian arteries to the arm both come off this brachiocephalic trunk. In cats, it'll be a little different, and in humans, it's a little different. And so you can see the carotids going towards the brain. The jugular veins will fuse with the subclavian veins to form the brachiocephalic veins and the two superior vena cava. So just as birds have two superior vena cava, so does this opossum. Whereas in humans, this empties and fuses just to make the one. In cats, the situation is similar to that in humans, in that the left subclavian artery going to the left arm does not come off the brachiocephalic trunk. So just like as in humans, the brachiocephalic trunk exists on the right side only, so that the left subclavian, the left subclavian will come off the arch of the aorta, and the right subclavian, let me just get a good, so I'm explaining it here, but obviously I put like a good point to pause from. The right subclavian artery comes off of, so the left subclavian is coming off the arch of the aorta. The right subclavian is coming off of the brachiocephalic trunk. So there's the brachiocephalic trunk underneath there. The veins, the subclavian veins from the arm fuse to make brachiocephalic veins left and right, which then fuse in to make the one superior vena cava, which empties into the right atrium. Right. So here you can see that the brachiocephalic trunk only exists on the right. The right subclavian going to the right arm comes off this brachiocephalic trunk, but the left subclavian going to the left arm only is coming off of the arch of the aorta. And humans are the same as we just saw. So from the arch of the aorta, once again, humans only have the left systemic arch. So our descending aorta tilts to the left, the right one does not develop. Then from there, we go to the subclavian artery, to the axillary artery, to the brachial artery in the arm, and then we have an ulnar artery and a radial artery. The ulnar artery is on the medial side because the ulna is on the medial side. The radial artery is on the lateral side. Now, the brachiocephalic trunk just like as we saw in the cat, is only on the right. So in humans, the right subclavian is coming off the brachiocephalic trunk, whereas the left subclavian comes off of the arch of the aorta directly. And then once again, in the forearm, there is an ulnar artery on the medial side and a radial artery on the lateral side. And then we would come back through similar veins, ulnar or radial veins, brachial vein, axillary vein, subclavian vein, brachiocephalic veins, superior vena cava.